Hi everyone, welcome to this lecture. So in this lecture, we will learn about the learning of neural networks in detail. If you remember in the introductory section of a neural network, we also learn that how neural network learns. And we saw that neural network learn in two stages or propagations, and that are forward propagation and backward propagation. But in that section, we discuss them briefly. But in this section, which is totally on the back propagation, we will discuss forward propagation and backward propagation in detail. So this is a neural network which we are going in order to understand the forward propagation and backward propagation. So we will use this neural network. So that is called standard neural network. So it has input layer, it has hidden layer, and it has output layer. So there are I neurons in the input layer. Therefore, we can also call it as ith layer. Similarly, there are J neurons in the hidden layer. So we can call it as jth layer as well. And we have K neuron in the output layer. So that layer is also known as kth layer. So we have input layer, hidden layer, and output layer, or we can say that we have ith layer, jth layer, and kth layer. Now we can see that there is a weight between the input layer and the hidden layer. If you see the subscript in the weight, it is Ji. So I is the first layer and J is the second layer. If we move from I to J, that is in the forward direction, then we are moving from input layer to the hidden layer. So in the weight, the subscript of the hidden layer or the second layer will come first, and the subscript of the input layer will come second. Similarly, if we see this weight, it is WKJ. So we are moving from J to K. K is our final position and J is our initial position if we move from J to K. In that case, the subscript associated with the final layer will come first and initial layer will come second. So it is Ji if we move from I to J, and this weight is Wkj if we are moving from J to K. So that notations are standard. Usually in the literature of back propagation, we saw this kind of abbreviations, we saw this kind of notations. That's why it is known as standard neural network. Okay, now if we see this neuron, the J neuron in the jth layer, we can see that we have written two things on that neuron, that is netj and oj. And similarly, if we see the output neuron, there are two things written on the neuron, that is netk and ok. So it is netj and oj, and it is netk and ok. Okay, now what is netj? So basically, netj is the input side of the neuron and oj is the output side of the neuron of the hidden layer. So netj is receiving input from the input layer and oj is the activation function of netj. Similarly, this is our output neuron. So it has two variables associated with that, that is netk and ok. Netk is the input side of this neuron and ok is the output side of the neuron. So what will happen, that netk represent the input which is coming to this neuron and ok is the activation function of that input. Let's see this neuron and this neuron in detail. So basically here we have a neuron, the output neuron. So this is netk and this is ok. If you see netk is at the input side of the neuron. So basically netk is getting all the inputs from the branches which are connected with this neuron. And when we have netk, ok is just the activation of netk. That is, if we have netk and if we have a sigmoid function as an activation function, then after calculating netk, we have to calculate the sigmoid of that netk in order to get ok. So if our activation function is sigmoid, then ok is the sigmoid function of the netk. That is, ok is the activation function of the netk. So that is our standard neural network. We have netj and oj, and we have netk and ok. Now we have clearly understood what does it mean, that netj or netk are the input side of the neurons and oj are the activations of that inputs which we calculated. Okay, let's start forward propagation in detail. So in the first step, we will calculate the equation of neuron j. That is, we will calculate the equation of the neurons which are present in the hidden layer. It means in the first step of the forward propagation, we are moving from input layer to hidden layer. Now let's see how to calculate netj. So here is net j. So what is net j? Net j is the sum of all the w and x1 which are coming from the input layer. Okay, so this is x1 xi and this is wji. So what will happen? This is the input to this hidden layer or the jth layer or the jth neuron. So if I multiply this weight with x, it will become wji and xi. So since we have a large number of neuron or we have I number of neuron in the input layer, therefore we have to take the sum of all the I neuron. So this will become input to the neuron, and also there is a bias associated. So therefore the total input to this j neuron will be the sum of the product of all the weights and the features plus the bias. Okay, after calculating a net j, what is oj? So oj is the activation function of net j. So here, if we are using an activation function as a sigmoid, so basically oj is the sigmoid of a net j. And we know that according to the equation of sigmoid, it is 1 over 1 plus e raised to power minus x. Since here we are calculating the sigmoid of net j, therefore instead of x, we have here net j. So this is the equation for the neuron which is present at the hidden layer. So this is the equation which we obtained in going forward. Now the second step in the forward propagation will be to move from the hidden layer to the output layer. Therefore, now we are going to find the equation of this neuron, which is the kth neuron. So now neuron K. So for neuron K, we have to write first the equation of net K like we did with this neuron, that is the jth neuron. And finally, we will take the activation of net K in order to complete the equation of a neuron K. So if we see here, K is getting input from the hidden layer. So what is the input? So input is the product of the input feature or input which is coming from the jth layer and the weight associated with this. So we have to multiply this. So we have WKJ and OJ. And since we have J number of neurons, therefore we have to take a sum of all the inputs which are coming from the Jth layer to our output layer. And then we have a bias associated with the output neuron. So this is our net K. So net K is the sum of all the inputs which are coming from the hidden layer to the output neuron. So the final step is to find the OK, that is the output of neuron K. And we know that OK is the activation of net K. If we are using a sigmoid as our activation function, then it will be 1 over 1 plus e raised to power minus net K. So in this lecture, student, we learn how to make the equation in the forward direction. We see what is a standard neural network. We see the notations used in the standard neural network, and we learn how to move from the input to output through the hidden layer, and how to make the equation for the neurons of the hidden layer, and how to make the equation for the neuron at the output layer. So I hope you understood the concept of a forward path. I hope you understood how to make the equations if we move in the forward direction in the neural network. Thanks for listening, and I will see you in the next lecture.